So over to you, and you can
Okay.
tell me when to move this. Tell me when to move the slide.
Okay, so thank you everybody. This is PMIP Wings number 5, and I will do a short introduction to PMIP latest news with Chris, and then we will give the floor to Natalie Burls about the Miocene project. Right, okay, so we thought we would give you some news about CMIP, WCRP, and things that are going on, and we will need to discuss those in the coming months, I guess. And I think you can go straight to the next slide, Chris, and comment it as well.
Okay, well, I guess I'll say a little bit about this. So if you were not aware, the discussions about the next PMIP have started. There are some decisions that have already been taken. I would love to tell you precisely what those decisions are, but I think it's still not at the point where things have been formally announced. It might even be that other people on this call know more than me, so that's fine, and they can chip in if I say anything that is incorrect. But the big picture, I think, is that firstly, there is going to be a CMIP 7. I suspect that's no surprise to anybody. And CMIP 6 was quite big. So the intention is to try and make CMIP 7 a bit easier to do and less of an ask for the modelling centres to complete. Quite what that means in reality, I'm not so sure. There is also a bit of an intention to tie in greater to climate services, which I guess would make it is perhaps a nice way of saying making sure that what we're doing is relevant to decisions that are being made now about, say, adaptation. But so that's sort of the big plan. I think we've filled in various little bits saying that PMIP would like to be involved in CMIP 7. So we've done that much, but I don't think, but we haven't been asked as a PMIP community to contribute things back and say what we would want to do. And but obviously that will happen, and we expect that to happen. And so I guess what I wanted to flag up today is that we're going to want to think about what has worked well in PMIP. There's a brief timeline on this figure that I've taken from a not final slide. So it's a suggestion of a timeline saying maybe sort of simulation starting about 2025. So we need to think about what worked well in PMIP, in the last PMIP, and we will be doing some surveys to try and elicit information about that. I saw this slide and was quite intrigued by it and thought I would share it with you, this is just from Working Group 1's technical support unit, and is in effect a list of the simulations that were used in the IPCC information provided by authors. And there are quite a lot of simulations across the board, but maybe you can see down there is the LGM, the Lig, the mid-Holocene, and obviously the mid-Pliocene are definitely featuring in here. And so they're sort of, we can see that that they are being used in the IPCC, these simulations. And so I think I just wanted to flag that
you have the last millennium just
oh yeah, the past one, yeah,
to the right.
Yeah. And so compared to, thinking about how many different simulations and protocols there were available, there's quite a few used, and the PMIP ones were some of them. So I felt that was a success story and thought I wanted to show it. But I think this is perhaps more of a flag of to get you thinking about what's worked well in PMIP for you as part of CMIP, and what you might want to see in the next version of CMIP, and because we will be asking for that information. So I think that's what I wanted to say. I'm going to pass over to you now, Masa.
Right. So I'm not sure how much news you've had from WCRP. WCRP is the World Climate Research Program, and it has reorganized itself over the last years. You probably knew about the core projects, so the yellow box on the bottom left here, and in particular, there's the Climate and Cryosphere project, which addresses long time scales and in which paleoclimate could have contributed more, or maybe could contribute more in the future. There will be a new, there's of course the Climate and Ocean Variability, CLIVAR, in which some of us take part. There will be a new core project on Earth system modeling and observations, which will include WGCM. That's the group on the working group on climate models, which has hosted the CMIP panel for some time. And so, oops. No, that's the, you should press the arrow, Chris, please. So, yes, so we could act more here. There is another place, there's another set of programs that are the lighthouse activities, that there are new activities that WCRP wants to highlight. And in particular, so there are 5 such lighthouse activities, and you see their titles here: Safe Landing Climate, My Climate Risk, Explaining and Predicting Earth System Change, Digital Earth, and WCRP Academy. And there is quite a lot of thinking in the Safe Landing Climate about paleoclimate, and I see Betty's here, so she can tell us more about it briefly if you want, Betty. We don't hear you yet, but
no.
Yes,
I had to find my my laptop's a little funky, so it's even hard to go between screens. So yeah, these different lighthouse activities. One of them is Safe Landing Climates, and its kind of charge was to look at tipping points, risks, cascading impacts on multi-decadal and longer timescales. So some of the others, like explaining and predicting Earth system change, are on maybe, I forget exactly, but probably seasonal to decadal. And so there's a little, there's interests across different ones. As we're doing performance evaluation, so I'm thinking of my director now. As Masa said, there are, I think, 5 themes. I should have pulled them up here. One is on high-risk events, one's on water cycle, one's on sea level. I should remember, one's on carbon, and I'm probably missing one of them in my head right now. The one I'm working on is the high-risk theme, and what we're looking at trying to organize to go across sectors is kind of these events that could happen. Sometimes people talk about tipping points, but interacting risk, cascading impacts, and in terms of right now, we're talking to a lot of the other community MIPs on kind of working with them, partnering with them, so the PMIP could be a partner on what we could do for CMIP 7 in terms of looking at extremes and tipping points. And there are 2 aspects. I mean, there's one is CMIP 7 will do the 1% to 4x CO2 and probably an extension, which is a deck experiment. So some of the modeling groups like the ice sheet modeling group or the land use modeling group will probably run that with, for example, a coupled Greenland ice sheet, or if they could, a West Antarctic or Antarctic ice sheet, coupled vegetation. It's not clear on that. But what we've realized thinking about these tipping points is the models may not have a tipping point in their design or that. So we have come up with a different MIP that we are kind of socializing right now. So PMIP might be someone we should talk to more closely, and we call it the what if MIP. So it's, you know, what would an extreme outcome look like that is not impossible? What could go wrong? So if there's a dieback of Amazon vegetation, what would its more remote effects be in terms of global effects and regional effects? So you get rid of the West Antarctic ice sheet. Some other possibilities, though I'm not sure PMIP might have to be the ones that push these forwards, is what if we have a greening of the Sahara? What does that mean about cascading impacts, interacting risks, or greening of the boreal forests? Those would be simpler experiments to do. Helene Hewitt likes those because they kind of relate to climate services. But again, we don't want to be in what if MIP, the group doing the modeling experiments, because we're not the ones that really connect to the ice sheet modeling community, except for a few members in that. So we'd like to partner with MIPS and be more the group that connects to those doing impacts, whether it's hydrologic, agricultural, financial, whatever. So that's something PMIP could think about in terms of, are there experiments, because you have the data. That's what I try to impress upon the people here at NCAR. We can connect to the future, but they don't have data for the future. So if there's something that could work, and we haven't proposed this yet to CMIP 7, because I'm still getting socializing with all the MIPS. So that's all I'll say, but people can email me, or if PMIP wants a Zoom call, Gabby Hegro is the other kind of co-lead of this high-risk theme in safe landing climates.
Thank you very much for that, Betty. Oh, I'll let Masa take over. Sorry.
You wanted to say something else?
I was just going to say, I think from what Gabby told me at the last WCRP joint JSC meeting, there was a comment that the safe landing climate should connect to paleo modeling and observations. So they would like us to do that. We just need to think how we're going to do it, if we're going to do it.
Right, and that's probably a theme for cross-cutting activities over several periods, and I think that's interesting in terms of where we'll go in terms of the questions we want to tackle in PMIP. Right, thank you, Betty. I think we can go to the next slide. So we talked about CMIP, we talked about WCRP, but PMIP is also, is not only embedded in CMIP. So I'm just putting this schematics to remind you how we are organized. So we were organized in PMIP 4. So PMIP 4 had some experiments, designed 5 experiments, which took part in CMIP. And these are the PMIP 4, CMIP 6 experiments. Miocene, LGM were the entry cards for PMIP 4, CMIP 6. And then we had the past millennium, last interglacial, and mid-Pliocene, simplest between quotes experiments. And these were actually the experiments that served as a base for additional experiments that were not taking part in CMIP, but were embedded in PMIP. And for example, from the LGM we had LGM sensitivity experiments to the boundary conditions. We have the deglaciation. For the mid-Holocene and last interglacial, we had the other quaternary interglacial. We had the whole PMIP suite of experiments derived, which took as basis the mid-Pliocene EOI 400. And then we have other experiments on pre-Pliocene climates and isotopes modeling. So not all PMIP experiments that are interesting to our community are officially taking part in CMIP. That would be very heavy to for modeling groups to do, and maybe not. And it's not desirable that all these experiments become compulsory for CMIP, and that would be too heavy for modeling groups. But it's important to say that we are still working on together collectively on these themes. And of course, this can evolve, and the talk by Natalie just in a few minutes time will show a proposition about the Miocene. So we have PMIP for CMIP, or PMIP 4, 5, it was PMIP 4 for CMIP 6, it could be PMIP 5 for CMIP 7. So these runs are performed with the same model version as other CMIP experiments for other MIPS, so that we can compare, rigorously compare these experiments, compare their responses to different forcings, compare past with future, and there are references for a larger community than just ourselves. And then we have, so for these experiments, it's really important to share model output on ESGF, so that this data sits next to the other MIPS, and people outside the community can also have a look at them. And then we have the PMIP 4 PMIP experiments, which sometimes are based on models with a simpler or simpler models or lower resolution versions of the model. They are usually longer durations, they are exploratory, they are sensitivity analysis, and that's really for better understanding past climate change and also exploring transitions. So we can design in PMIP 5, for PMIP 5 or for the next phase of PMIP, we have a good basis, and I think some of us are still running their PMIP 4 experiments, and this could contribute to PMIP 5. But we can also discuss a little bit more about additional experiments and where they sit. Okay, I think the next slide, yes. And the next slide is on PMIP organization, to keep you posted. So there are new names that you see here. I put them in for working groups on periods. So for example, for the past millennium, we have Chong and Miriam. I'm watching here. Yeah, they're here. On quaternary interglacial, we have Christian and Louise. The last deglaciation includes the LGM as a basis. And so we have quite a lot of people here. PMIP has new people in the leading group. Tamara ran and have joined Alan and Harry. And on pre-Pliocene climate, we have Dan, of course, and Natalie for the Miocene. We also have working groups on topics, cross-cutting topics. So there's the past to future and variability working group with Kira and Chris, monsoons with Yang and Jan, and we have the link with the reconstructions, and probably we are expecting new people here. So we would like to have new people here. And then we have infrastructure. So today we will talk about a new period, and that's also for people to be acquainted with this new period. And so I will give the floor to Natalie. I think I'm done now.
I'll stop sharing then.
Yeah, thank you.
Thank you. And so I think if we move to Natalie, and then we'll aim to have some questions and discussion after Natalie's talk.
Thank you. So off to the Miocene.
Yeah. But obviously, if you've got questions now, you can write them in the chat, and so we remember for later. But yeah, so I'll pass over to you if that's okay, Natalie.
Sure. Thanks, Chris, and thanks for the invitation from you and Masa to give a brief presentation about what we've been doing for the Miocene. So yeah, I'm excited to just go share with you today some work that's come out of a MIP of opportunity study, which we've named MIOMIP 1, and then also some efforts towards a coordinated model into comparison effort for the Miocene. See if I can advance slides. Great. Okay, so just to give a bit of motivation for the Miocene, so thinking about 400 ppm plus worlds. So leaving the Pleistocene, we arrive at the Pliocene. And then in terms of coordinated MIPs, we've also had efforts through DeepMIP for the Eocene. But the Miocene is a particularly interesting time. As you can see here, it sort of fits in between the two in terms of it being a very dynamic climate. I'm pointing out here the temperature, so sort of somewhere in the range of what we could see in the next century. And then also a bit of a question mark here for the carbon dioxide levels, because there's sort of new data coming out all the time and revised estimates, particularly for the MCO, which is sort of the peak warmth during the Miocene, and just how high CO2 levels could have been during this time. So as a result of this question, what can we do towards thinking about a model into comparison for the Miocene, given its interest? This dating in 2019, in June 2019, there was a meeting in Stockholm between a number of Miocene modelers. And to get the ball rolling, the suggestion was raised, well, why don't we just do a MIP of opportunity, right? So taking our current models that are out there and coming together as a community and looking at what we're seeing and what's the range of estimates that we see across the various simulations that are out there. So I'd like to acknowledge all the co-authors that are listed here from the study, but these consisted of the group of modelers that got together, and for better or for worse, I said, I'll try and coordinate this. This became the pandemic paper, and at the time, not realizing that in 2019. But all of the modelers listed here, and we also had some observationalists, came together and said, that they would contribute their already published Miocene simulations. And so this slide sort of summarizes what was available at the time back in 2019. And so we had some groups that had targeted the early Miocene, and those various models that had already some published simulations are listed here in blue. So we had some CSM simulations, CCSM simulations, Hadley model, IPSL, and NORISM, and then also some slab ocean models with Genesis. And then we also had some groups that had done some simulations looking at the late Miocene, so Cosmos, some Hadley simulations, both by Catherine Bradshaw and Alex Farnsworth, as well as some orbital sensitivity experiments as well. And so the first step was to synthesize these, and all the previous modelers contributed their data, and we wanted to put it in a sort of a consistent analysis framework. So one thing to keep in mind, this was not a coordinated MIP, right? This is a MIP of opportunity. So obviously every modeling group had at the time made very different decisions about the boundary conditions that they were going to use. And so we had a range of different paleogeographies going into each of these simulations. Here I'm just summarizing that. So some of the models had used the Herald boundary conditions. There was also one simulation that used an updated version of the Herald boundary conditions, which we published as part of that paper, this MIP of opportunity paper. Frigola boundary conditions had been used, GTEC, all of these as a variety of different, and some updated versions of the Heralds for the middle and early Miocene. And then for the late Miocene, we also had 3 different boundary conditions that had been used by the modeling groups. So just a little bit of a summary here to give you a feel. These were the contributions that went into the late Miocene experiments. Note that different decisions had been made for CO2 concentrations, for the Greenland ice sheet, the Antarctic ice sheet, and again, the paleogeography. So the tables on the paper just sort of summarize that, and you'll see that we landed up binning the simulations by approximately the CO2 ranges that they were in. Again, far more simulations going into the middle Miocene, so it's targeting 15 MA or 15 to 20 MA here. And again, a range of decisions for the CO2 concentrations being used, as well as the extent of the Greenland ice sheet, the Antarctic ice sheet, and then the paleogeography that went into the simulations. So here's a sort of the summary figure that went into the paper. This figure is all the simulations, so both late Miocene and middle Miocene. And you can see there on the x-axis have the CO2 forcings that were used by the various modeling groups, and then their global mean surface temperature for each of the models. And then in the shading here, I'll get to that later, but that's some data constraints, some data estimates for global mean surface temperature. One of the main things I'll point out is that if you run a best fit regression to that, so the dashed gray line in this figure, we're landing up with about a 2 degrees Celsius warmth just from the changes in boundary conditions. As you can see, there's a lot of spread in that estimate across the modeling groups and the different models, but on average, a suggestion of about 2 degrees of warming as a result of Miocene boundary conditions alone with no CO2. And then CO2 sort of emerging as the strongest control on global mean surface temperature across the simulations, with about a 0.97 degrees Celsius per watts per meter squared. So approximately 3.6 degree per doubling estimate for the best fit for the climate sensitivity. And so here I've binned, again, those experiments in terms of their CO2 concentration now. So as I said, there were a range of different CO2s, but close enough. So the experiments that are all around 280 ppm, 350 to 340 ppm, 500, and then the 840 to 850. And as you can see, there's quite a variety of things happening, particularly over Antarctica, and that a lot of that comes down to the different choices for the Antarctic ice sheet. But this just gives you a feel for what we're sampling with these experiments. In terms of the warming patterns, so again, this is binning into the different CO2 concentrations. And so that, the 280 ppm in the top row, then going up in terms of your CO2 concentrations to something between 350 and 450, the 560, and then the higher CO2 concentrations around 840, 850. And so you can see this is the multi-model mean in each case, with the polar amplified warmth and some continental amplified warming occurring. But then the figure on the right shows the standard deviation across the simulations going into the multi-model mean. And so you can see the regions of strong standard deviation, again, associated with the different Antarctic ice sheet choices, as well as over land. You see some high standard deviation across the models popping out in Northern Africa, the Tibetan Plateau region as well, again, some paleotopography choices. And then when we focus on sea surface temperatures, again, we do see a polar amplified warmth with the amplified warming in the North Pacific and the Southern Ocean, as well as in some of the ensemble means. And again, these are different models going into this. So the ensemble sizes are also changing. That's not standardized. Another thing to keep in mind. And then some indication of amplified warming in the Eastern Equatorial Pacific at the 850 level. And again, when you look at the standard deviation plots, it points to, particularly things like where western boundary current regions, where we have strong fronts and shifts in that. And that's probably, again, kind of related to the different choices in paleogeography. And you can see that popping out with the masking as well. We just did a very simple zonal mean energy balance model assessment of what's sort of driving these changes in the zonal mean from a zonal mean perspective. And again, there's caveats with this approach when you get over ice sheets. So, take it with a pinch of salt, the cloud shortwave versus the surface albedo signals over the high latitudes. But we see again large changes, and the spread here is, so I've got the ensemble mean, and then the spread is across the simulations, and this is for, these are for the middle Miocene simulations. And so again, you can see the impact of having a very different Antarctic ice sheet choice. They're giving rise to, some very warm simulations over Antarctica and some moderately warm simulations. But interestingly enough, one of the take homes from this was that for the tropics, it's really the CO2 and the greenhouse forcing associated with that that's the dominant signal determining the degree of tropical warmth here. And if I go back maybe to this slide, you can see some experiments have very different Antarctic ice sheet sizes and very different degrees of warming occurring over the Antarctic, but moderate changes, relatively moderate changes propagating into the tropics with CO2 concentrations. That's not to say that, through Southern Ocean teleconnections, it's not an important mechanism, but in terms of the relative role of that versus CO2, CO2 is the dominant forcing coming out of this evaluation. All right, and so then the next thing we did as part of this MIP of opportunity paper is we did a model data comparison. This was a very first stab at it, and I will speak a little bit to how the community is working to do a better job. But at the time, there was efforts to put together the Berlin Center portal. So this is a Miocene temperature portal that's been hosted by the Berlin Center in Stockholm. And it was put together by Kira Lawrence and Helen Coxall, Cynthia Sossadine and Marguerite. And this is now going into community efforts as a starting point. And it also was the synthesis we did for this paper sort of set the stage as well. So we took all the available sea surface temperature records from both TEX, magnesium, calcium, and alkanones. And we very crudely just binned them into late Miocene and middle Miocene. We didn't do any recalibrations. We didn't do any age model adjustments. So all of these things that we should have done are going to be done. But for the purposes of this paper, we just wanted to get a first feel for it. And so here you see on the right are the late Miocene sea surface temperature estimates that we had, and the middle Miocene sea surface temperatures. And then we've just fit through it a very simple polynomial model with the coefficients being determined by the best fit for the data. And that's what we use to back out our global mean surface temperature estimates. So I made the point about the temperature portal. And so for the global mean surface temperature estimates there, there's also the land data that came from pollen assemblage that was compiled by Matthew Pound. So on the, and those are shown in green dots here. So when you take both the mean annual temperature estimates from the land sites, as well as the sea surface temperature proxies, and you do this best fit, we came up with some estimates for the late Miocene global mean surface temperature, putting it at about 19 degrees, 19.3 degrees plus minus. And interestingly, when you just did this best fit based on the sea surface temperature proxies only, you actually get a slightly higher estimate for the late Miocene of about 21.5, sorry, 0.9. Similarly, for the Miocene, focusing on the larger middle Miocene time period, there was the estimate of about 21. And again, this gets pushed up if you just use the sea surface temperature proxies. And again, just in a best fit point of view. So really fitting our equation to and backing out our coefficients to the data that you see here in these plots. And then we also focus just on the MCO. I don't have that here, but obviously you'll use a lot of data points if you just focus very narrowly on the sort of 15 MA slice. And then we got an estimate of about 22, and if SST only as high as 25 degrees. So that's how we came up with the sort of estimate and uncertainty bars shown here as a comparison. So the green is our late Miocene, the gray are middle Miocene, and then the MCO in red. And then that's the shading. So let me just use my pointer here. This is the shading here. And then we have the SST only estimates with these crosses. And so you can see just looking at the SST proxies only pushes everything up a bit. So one of the take homes here is you need sort of the models that have higher CO2s are getting into at least the global mean estimates for the MCO. But none of the models with the 400 ppm of CO2 forcing are getting warmth to the same degree as the MCO. And for the Miocene, the 560 simulations are capturing the degree of warmth coming from their reconstructions. But as I'll get to next, none of the models are necessarily capturing the degree of polar amplified warming and the changes in the meridional temperature gradients that the proxy data suggest. So there's two different metrics in this figure. The first metric is for the tropics, 30 south to 30 north, minus the high latitudes, so 60 to 90. And we just, did our area weighted means and took the difference between these for the models. And then we used our zonal mean estimate from the proxy data. And again, we've got the green as the late Miocene, the middle Miocene is in gray, and then the MCO is in red. And so it seems to suggest that very few of the the models are simulating polar amplified warming, but not to the degree, at least from our first stab at estimating it from the proxy data. And then very interestingly for me, because I think this is really important for the Hadley cell and the hydrological cycle response, having based on some previous work looking at this for the Pliocene, is this gradient between the tropics and the mid-latitudes. And so we see that being considerably weaker from the perspective of the proxy data, but not necessarily in the models. And I think this could play a big role in why the data suggests the subtropics were wetter during the Miocene, whereas the models don't necessarily simulate subtropical wettening during the Miocene. And there's been previous work that speaks to this as well, the importance of the meridional temperature gradient on getting the hydrological cycle right. Here's a few plots that show this spatially. So for the middle Miocene, when we look at the proxy model data comparison, we see that the best fit, it's the root mean square error, best fit is shown here in red in the bottom left of each subplot. And we have the 5.1 root mean square error. I would take this with a pinch of salt. We have to probably revisit some of this, and especially the approach for the model data comparison. But in particular, you'll notice that the proxy data for the North Atlantic is very warm. This is both TEX and alkanones. And so none of the models are at any of the CO2 concentrations are really getting the degree of warmth that we see in the North Atlantic from the proxy data. And then you kind of start to overshoot at very high CO2s in the deep tropics. So you start to see the sites indicating that potentially the models are getting a bit too warm in the deep tropics at the higher CO2 concentrations. And that's also evident here in the zonal mean. And then what's really interesting is this is a completely independent data set. This is the mean annual surface temperatures coming from the pollen assemblage data. And similarly, you see the similar story where the high latitudes are not warm enough, cold biases over land. And then as you start to get into the tropics, and particularly at the high CO2s, potentially we're getting too warm in the deep tropics and the subtropics at the higher CO2 levels. And then interestingly, from a land perspective, the best fit is 560 ppm with the data. I'll just quickly go through this in the interest of time, but for the late Miocene, we did a similar thing. And again, the model's not really capturing the warmth that the data suggests for the North Atlantic. Oh, by the way, I wanted to make the point that we have very little data in the North Pacific. I think some is coming online from Tim Herbert's group and others, but that's a real data gap for us, and it would be nice to validate some of these signals. Is this just this North Atlantic warming happening in the Pacific as well, or is it purely a North Atlantic phenomena? And yes, again, we have at least a little bit to fill in here, and at least for the late Miocene, it would seem that it's the extreme warmth occurring in the late Miocene is isolated to the North Atlantic, and the models are doing a better job with the North Pacific. In fact, some data would suggest that at 560 ppm, it's too warm. The models are too warm. But again, only one model going into the 560 ppm estimate for this ensemble of opportunity. And again, somewhat similar signals. Unfortunately, all the data is in the Northern Hemisphere, and it's all clustered on Europe. So we should zoom in there, and we plan to do something a little bit more regionally focused for some of this. Okay, so just to summarize this piece, there was a MIP of opportunity with MIOMIP1. And we undertook a synthesis of the Miocene modeling efforts, and mostly compared them with surface temperature reconstructions, and presented everything within a single analysis framework. This prescribed CO2 forcing as the primary boundary condition, controlling the global mean temperature, and surprisingly, I suppose, right? We saw that the strong regional warming in response to the prescribed changes in the Antarctic ice sheet, but the influence beyond the Southern Hemisphere high latitudes was limited. The Miocene global mean temperature estimates spanned anywhere from 3 degrees of warming to 12 degrees of warming, and then as a function of the CO2 concentrations prescribed, and then the boundary condition only warming was about 2 degrees Celsius in the non-CO2 forcings. And then some model simulations with higher CO2s overlapped with the reconstructed global mean, but the models failed to capture the weak temperature gradient. So yeah, just a little point to make here. We did publish the surface temperature data and the sea surface temperature data, because that's what we analyzed for this paper, and it's available through Zenodo. I also put the code used to make all the plots and do the analysis in GitHub. So if anyone's interested, please feel free. And also the data that was used for the model data comparison, the proxy data estimates. And as I said, there's efforts to update this. All right. So just in terms of what we're thinking as a community right now, we're kind of posting updates on the DeepMIP website under DeepMIP Miocene. We have this MIP of opportunity paper that's being published, but we also have some further ones that are planned, because we only really looked at surface temperature in that paper. And so there's an effort being a paper currently, I think it's fairly close to submission, by Paula Costa and others, looking at how the hydrological cycle responded across that MIP of opportunity and comparing that with some estimates of mean annual precipitation. We also have Trusha leading a MIP of opportunity paper looking at what ocean circulation is doing in those simulations. And then we also, as a community, have been meeting for every month for the last 6-7 months now already, thinking about a formalized Miocene model into comparison experiment. And so we're working on an experimental design paper right now. So why? What's the motivation towards a MIOMIP2 formalized into comparison project? Well, I think I spoke to this a little bit at the beginning of the talk, but there's some questions around climate sensitivity and the pattern effect for the Miocene. Modeling the magnitude of the large scale gradient patterns and following up on this indication from the first pass that the models are not getting the right degree of polar amplified warming. Ocean circulation and the role of gateways is a very interesting question. A lot of the modelers are interested in pursuing, thinking about ocean biogeochemistry and the carbon cycle changes. We know there were big carbon cycle changes and CO2 changes going on throughout the Miocene. So the role there, plant biodiversity with a shift to C3 to C4, and also evolution, human evolution-wise, a number of groups interested in that. How and why the ice sheets fluctuated, changes, and the sensitivity of ice sheets. So all of this very important for thinking about future projections. And then sea ice as well. And then what caused the CO2 to fluctuate, which kind of ties into our carbon cycle. The role of orography, the role of soil type and vegetation, because we had very different vegetation changes. And then we also interested in the model response, right? One of the main things, the spread in the response to having common set of boundary conditions. So just in terms of the modelers that have signed on, this is a list of everyone that has indicated an interest in running simulations. And we have a number of groups that are interested a few different versions of CSM and IPSL models, GFDL model, had CM, F goals, AWI, and the NORI-SEM groups have indicated an interest in conducting experiments that come out of the experimental design paper. And we're also doing a sort of phase 1 this summer, running with the updated Herald, and some modeling groups have signed on to that. And then obviously for the experimental design paper, we've had to engage a number of observationists. So we've consulted the Miocene CO2 community, particularly because of these higher CO2 estimates coming out for the MCO from boron. We've also engaged a number of modelers, and Nikki Wright in particular has been helping lead the charge for thinking about how we might update the Miocene paleogeography, and particularly thinking about Antarctic bedrock, and then also orography and orograph, mountain ranges, with a number of papers being published since the last Herald paleogeography. Miocene ice sheets, we have Jules and Leonard have been leading a Miocene ice sheet group, thinking about what the prescribed boundary conditions should be and the best estimate for the MCO. And then hopefully at some point we can also start thinking about the transition and the late Miocene. And then there's also Catherine Bradshaw's been leading an effort thinking about Miocene vegetation. And we've trained a number of proxy folks for that, which is great. And then my last slide on this point was just to say, a lot more thought is going into the sea surface temperature proxies and reconstructing best estimates for sea surface temperature during the Miocene, and with a focus on the MCO and the late Miocene. And so there's a PAGES working group, Myo Plio Bar, with Cynthia and Sevi leading a workshop we had in January, and then another one that's going to be had at Myo Meet now in Utrecht in June. And so that's in training a great amount of the Miocene proxy community to think about best estimates and do a much better job than we did for the MIP of Opportunity paper. But it was a first stab. And with that, I'll conclude.
Thank you very much for that. That was great. I'm going to stop the recording now, and so I'll do that.